Okay, welcome to my first bridging between GCSE and A-level section. I'm going to be looking at first kind of the most basic really, and that's where A-level seems to start, and that's looking at indices and surds. I've taken all these questions from physicsandmathstutor.com. There's some really great resources on there. I use them so much, and they're free to use, and I thought I'd better give them a little bit of a shout out really, because they're excellent. So if you're ever at the beginning of the stages or the end, go to physicsandmathstutor.com, and there's loads of practice stuff for you. So that's where I would go. That's my go-to. Okay, so starting off with surds and indices. So the first question we're going to look at is, now you've got two surds here, root 75 minus root 27. On this question, there's not really much, the difficulty level on this isn't too great. It's just that the difference with A-level is they tend to ask in this, the forms slightly different. Form K root X, that's just no reason, that's just slightly, I've noticed the terminology is slightly different. It's actually no different to GCSE. So root 75, hopefully you know how to simplify surds. So root 75, there is a square number that goes into 75, and that is 25. So if we take out, I like to use like these trees, because root 75 is the same as root 25 times root 3. Okay, and what is the other one? Root 27. Think of a square number that goes in 27 is 9. So root 9 times root 3. Okay, so now what we've done, we've taken out the square number of both of these, and so we've got root 25, which changes to 5, and then we don't need the times there, 5 root 3. That means 5 times root 3, but we don't really need it. And this one, we're going to minus, as you can see the question is root 75 minus root 27, minus 3, and then root 3. Okay, and you can deal with these because the base numbers are the same, root 3's. You can deal with them, you can literally just take one away from the other. 5 lots of root 3, take away 3 lots of root 3 is 2 lots of root 3. So when you get to that point, it's really easy. It's just remembering that's what you need to do. You can't take them away unless they have the same base number, or add as well. It's just like fractions. The base number is sort of similar to the denominator in that way. So you need to break it down so they have the same base. Okay, so going on to our next question. Feel free to pause these, by the way, watch how it's done, or maybe watch a couple through, follow it through, and then do maybe a couple of the later ones. Okay, so expand and simplify. So this is just like any other expanding brackets. And if I was starting out and you weren't sure about expanding brackets very well, I would often use a like a table method. I quite like this really, and it especially when you're using when you've got surds, because it's quite easy to get mixed up. So you can do it like this because you're timesing everything in the first bracket by everything in the second bracket. So 7 times 3 gets you 21, and then 7 times minus root 5, minus 7 root 5, and then 3 times root 5, 3 root 5, root 5 times minus root 5, give you minus 5. Now that's because you end up with minus root 25, and root 25 is just 5. And you're squaring, so you're undoing the root really here. So that will always happen when you've got two roots of the same base. You'll always end up sort of getting rid of that. Okay, so if we just write all these out, we've got 21 plus 3 root 5 minus 7 root 5 minus 5. Okay, and then you're collecting like terms. You've got 21 minus 5, so that's 16. 3 root 5 minus 7 root 5, you have minus 4 root 5, and then that's it really. That is the final answer. So you've just expanded it out and simplified it. Okay, you normally get a couple of marks for doing that. Okay, so moving on to the next question. You can see this is part A of our question. Actually, part B is linked to that, and you'll see that in a second. So here you've got 7 plus root 5 and 3 plus root 5 underneath. Now what this is called, because we have a surd on the bottom, what we have to do is rationalise our denominator. Now that means get rid of the surd on the bottom, basically. So, and to do that we have to multiply it by the conjugate pair. So I'm just going to write it out again here because I quite like it in order. So I need to times it by the conjugate pair over the same number, okay? And the conjugate pair is basically exactly the same as the number on the bottom, but with the opposite sign. So this is the first one is a plus root 5. I'm going to minus root 5. Okay, so that's the conjugate pair. And then if you times it by this, the same number over itself, that in effect means you're just timesing it by 1. Okay, so hopefully you're all aware of that. Again, if you need to go back and look over how to do this, this is rationalising the denominator with 2 terms at the bottom. So 7 times 3, I get 21. I'm just going to do these. I'm just going to literally times them out at the moment. So you can stop the video and do this a bit slower if you want to, and see where I'm getting all my things from. Okay, so there's the top, and as long as you remember that you need 4 terms, you've got 2 terms on the top, 2 terms over here, so it's going to end up with 2 times 2, which is 4 terms. They're all different as well, which is great. And then again with the same, so 3 times 3 is 9. And then what have I done? 3 times 3, and then 3, and then 5 times root 3. So 3 times minus, so minus 3, and then root 5, so it's just minus 5 there. And so again, we've got 4 terms on the top, 4 terms on the bottom, and we can just simplify. So the numbers, 21 minus 5, you have 16. 3 root 5 minus 7 root 5 minus 4 root 5. And then on the bottom, you'll notice this is where we get rid of the surds. 3 root 5 take away 3 root 5, 3 root 5 take away 3 root 5. You end up cancelling out. So you are just left with 9 minus 5, which is 4. And this is great. This is in a format, but you can hopefully you can see that all of these terms actually are divisible by 4. So you can actually divide the whole top section by 4, and I'll show you using I'll take it out as a factorising first of all. All I've done is factorise, divided the whole thing by 4. So 16 divided 4 is 4. Minus 4 root 5 divided 4 is just minus 1 root 5. And then I've got 4 on the bottom, and I can just cancel out there, and I'm left with 4 minus root 5. Okay, so that is a slightly harder, I suppose, rationalising denominator and then cancelling down. So hopefully you followed that. Again, this is definitely still in the GCSE, but it's one that comes up in the A level and very much worth practicing if you're not too confident on that. Okay, our next question is here, 32 root 2 equals 2 to the power a. Now what you need to look at here, you've got all of these you can put into as base 2's. Now base 2 means that 2 to the power 1 equals 2, 2 to the power 2 is 4, 2 to the power 3 is 8. It's going to keep going until I get 2 to the power 5. Okay, so 32 as a base 2 is 2 to the power 5. Okay, now this 32 root 2 means 32 times root 2. Now root 2 is what is that then? Okay, so this is where you have to think of your index rules, and if you think about the root of 2, that is going to be 2 to the power of a half. again, one to really just remember. So if you see it like that, you can just change it straight back to it, so it's got an indice there. Okay, so 2 to the power of a half equals 2 to the power a. So now what we've got here, that all three terms, all three things are in base 2. And now you have to think about index rules. So you've got 5, and when you're timesing index rules together, remember you're adding them. So it means that 5 add a half equals a, basically. You're kind of discounting the 2's for a second. So 5 plus that equals a. So therefore a equals 5.5, really, isn't it? Or 5.5. Okay, so again, you probably may or may not see that GCSE, it's probably in there, but quite often they use that quite a lot, that kind of proving things and finding values using that. And that's quite a straightforward one. Okay, so I hope that was quite clear. And the next question we're going to look at is some fractional indices. So this one's quite straight. Again, there's nothing too hard with any of this, really, especially if you're looking to do A-levels. You're probably a good grade at your GCSE, so you should know these, really, but let's just make sure that we do. So 125 to the power of the third. Now you have to remember that when you're doing fractional indices, this bottom denominator is what you put above your root here. So you literally put it into a root. Now the one at the top kind of goes there, but when it's a 1, it doesn't make any difference. So what is the cube root of 25? Well, that's just going to be 5, because 5 times 5 times 5 equals 125. Okay, and obviously to the power of 1 will just be 5. This one is fractional and negative. So with negative, you flip, say for example, this is 125 over 1. You flip the fraction so that it's now 1 over 125. And that gets rid of the negative, but you still need to worry about this to the power of 2/3. Okay, so power of 2/3, we know the power of 1/3 because we've just done it there. Power of 2/3, so you'll end up with the cube root of 125, and then the numerator is 2, so then you'd square that. Okay, we didn't need to do that on the first one because it was a 1, so we end up with 1 over, and then so we'll have 5 squared 25. You would actually do that to power of 2/3 with the 1, but 1, because when you cube root a 1 or square root a 1, it just gets you 1, so you don't actually need to perform that on that one, but you would have to if it was a fraction, then you might have to perform it on both top and bottom. Okay, so the answer to that one is 1 over 25. Okay, the last question I want to go through is very similar to what we've done. It's just making this, there's slightly more to do with the bottom part of this, which we'll go through. It might be good for you now to pause the video, because I have had a go at doing very similar ones. Have a go and then see on the answers in a moment. Okay, so root 45, if I think of that as a square number that goes into 45, is 9. So we'll take that out and I'll times 9 by 5 to get that. And so we're going to be left with 3 root 5. Okay, so that's just root 45 is the same as 3 root 5, and that's it for that one. Now this is where this is slightly harder, I suppose. So again, you've got this, we've talked about this earlier, this bottom, the denominator has got a surd in it, so we need to multiply it by something to get rid of it. And we multiply it by the conjugate pair as a fraction. Okay. I'm going to rewrite this out again. And then 3 minus root 5. I like to do this just for neatness, really, just if you've got that there. So I times it by that. So I'm timesing the bottom and the top by the same thing, again, because that's a value of 1. So 3 times 3 is 9. Obviously, you can pause this and do this slightly slower if you want to do the table. And then 3 times root 5 is plus 3 root 5, and then 3 times minus root 5, so you'll get that. You can always just discount that if you wanted to, because you know that it cancels out. But while you're practicing, I would keep it in. Okay, now this one, you've got 2 times this, and then this times this again. So you've actually kind of got, and it's not 3 brackets, but kind of 3 timesing it 3. What I would do is times the bracket, and then put the 2 on the outside, just to see what it looks like, and see if there's anything we can do simplified wise. So 3 times 3. So I'll leave the 2 on the outside for now. So that's 9. And then 3 times root 5. And then, what have I done here? That times that. And then root 5 times 3 again. So it's the same thing again. And then plus root 25, which is just the square root of 25 is 5. Okay, let's close the bracket off. All right, now let's just simplify this down. We'll leave the 2 there still. 9 plus 5, you get 14. And then 2 lots of 3 root 5, so it's 6 root 5 over 9 minus 5, 4. And then obviously, as you should know this now, these 2 cancel out, plus 3 root 5 minus 3 root 5. So we just end up with a 4 on the bottom. And there is actually more simplifying you can do here, because you've got 4 and a 2 here. You could cancel that down, but what you also can do, this is the thing about spotting things really, in the middle part here, both of these are, the 14 and the 6 are both even, so you can divide those out so that so you times the 2 by 2 and you divide in whatever's inside by 2. So you've kind of divided the middle by 2 and times the outside by 2. Sorry, that 4 looks a bit weird. That should be a 4 on the front there. Cool. And then again, we've got 4 times this, and then we can cancel those 2 out. So we're left with a very much easier to look at. 7 plus 3 root 5, because they just literally cancel out. 4 over 4 is 1. So cancel it out, and then you're just left with that is what is on top. And if you look back, once you've done your question, you think, oh, I get that, that's brilliant. Look back to make sure it's in the format they expect. There's a number there, and you're adding it or taking it away, which doesn't really matter. The root 5, and I have got a root 5 at the end. Okay, so that's the question. Again, nothing too far away from GCSE. This whole point here is building them bridges, making sure you're really confident on your GCSE type stuff, the stuff that is going to come up again in A-level. So basically don't forget it, and just keep practicing. If you don't understand these, again, this is another rationalizing denominator. So this one is probably the most straightforward kind of bridging. Next time I'm going to be doing quadratics. There's a lot to do with quadratics. It might be a bit of a longer video, but please feel free to comment down below, subscribe to see more videos, and take it easy.